Wave number 2. Then this is called as an amplitude. Amplitude of wave 1. This is also amplitude of wave 2. These two are mixing with each other to form a wave whose amplitude is the sum of the amplitude of these two waves. That is called as constructive interference. Resultant wave. Amplitude equal to amplitude A naught. This is also amplitude A naught. This is also amplitude of the resultant wave 2A naught. Then this is called as constructive interference. Constructive interference. Like that, the wavelength crest of one wave and trough of one wave are combined with each other, and the amplitude is decreased. Wave 1. Wave 2. Wave 1. Wave 2. Then the resultant wave is not there because resultant amplitude equal to 0. A naught. Here also A naught. Resultant wave A naught minus A naught equal to 0. Then this is called as destructive interference. Crystal structure by using the station. Now, forms right angle triangle. A, B, interspacing distance D, and this is the location of an atom Z. completed. The first point, X-rays of single wavelength, X-rays of single wavelength lambda strike the parallel planes, strike the parallel planes of the crystal at an angle theta. Some planes are some X-ray are reflected from the first line. Some of them are from the second line. Some of them are reflected from the third line. Like that, it is an integral multiple of wavelength. Some lines are reflected from first plane. That means from the upper plane. Some from the second plane. Some from the second plane, and some from the third plane or lower plane. The waves reflected by different layer planes will be in the phase path length of the wave. That's why that successive planes are equal to integral number of wavelengths. Observe here from the diagram. Here first ray is reflected from the upper plane, second ray is reflected from the second plane. Some of the rays are reflected from the lower plane. From that, with the phase difference d, that's why it is an integral of lengths. The waves reflected by different layer planes different layer planes will be in phase. If the difference in the path length of the waves reflected from path length of the waves reflected from successive planes. Is equal to an integral multiple of or integral number of wavelengths. From the graph, AD and AC are perpendicular down to the incident and reflected beams. A and AC are perpendicular down to the incident and reflected beams. The difference in path length of the wave deflected from the first two planes, deflected from the first two planes is given by AD plus BC equal to n lambda, n equal to 1, 2, 3, and so on. Sort of. Complete, ma? So wait. Sir, complete, sir. That one. Since triangles AD or ABD and ACB are congruent, then DB equal to BC. Then DB plus DB or BC plus BC equal to n lambda is equal to 2dB or 2BC, which is equal to path difference. As D equal to D sin theta. Then path difference equal to 2D sin theta. Hence, condition for maximum reflection equal to maximum reflection is n lambda equal to 2D sin theta. And this is called Bragg's equation. The interspacing distance can be calculated by using a Debye-Stirner method. The value of D can be calculated by using a Debye-Stirner method. By using the same X-ray monochromatic beam source. Point number one. Point number two. The values of D in the direction of sodium chloride, in the direction of sodium chloride, direction of different in the direction of different coordinate axis in sodium chloride crystal or in the ratio 1 is to 0.703 is to 1.134 by substituting angle theta. Completed, sir.
Sir, complete, sir.
Question number 1. An X-ray beam an X-ray beam 70.9 picometers was scattered by a crystalline solid was scattered by a crystalline solid was scattered by a crystalline solid. The angle 2 theta of the diffraction 2 theta of the diffraction for a second order reflection for a second order reflection is 14.66 degrees. Calculate the distance between calculate the distance between parallel planes of atoms. Parallel planes of atoms of the crystalline solid of the crystalline solid. Now look at here. An X-ray beam of wavelength is given as 70.9 picometers was scattered by a crystalline solid. The angle is 2 theta, that is deflection angle of the diffraction for a second order. Second order means n equal to 2. Second order means n equal to 2. Wavelength is given. Then formula for that equation is n lambda equal to 2d sine theta. Here n value is there, lambda value is there, sine theta value is there, but d value is not there. That means calculate the distance between parallel planes. That's why we need to calculate the value of d. Then order of reflection is 2. 2 lambda equal to 2d sine theta. Then d equal to lambda by sine theta. Then 2 theta equal to 14.66 degrees. Then theta equal to 7.33 degrees. Two theta equal to 14.66 degrees. Theta equal to 7.33 degrees. Then 1 picometer equal to 10 power minus 12 meters, which is equal to 70.9 into 10 power minus 12 meters by sine of 7.33 degrees. Which is equal to 7.09 into 10 power minus 11 meters. Zero point 8658 times 7.33 degrees equal to 0.8658. Eight point 18 into 10 power minus 11 meters.
Complete, sir.
Okay. The next question. Question number 2. Xenon crystallizes in phase and I already completed. Sorry. If the radius of an atom of an element, if the radius of an atom of an element is 500 picometers, if it crystallizes as if it crystallizes as a FCC lattice, what is the edge length of the unit cell? What is edge length of the unit cell? For FCC, radius r equal to a by 2 root 2, then edge length a equal to 2 root 2 into r, it's equal to 2 root 2 into 75, so 500, 500. 2 root 2 into 500. No doubt.
Yes, sir. Complete, sir.
is equal to 1414. 1414 picometers. Next question. Packing efficiency of a unit cell. Question number 3. Packing efficiency of a, one second. Packing efficiency of body centered cubic crystal in which atoms are present at corners as well as body diagonal is 68%. Atoms at corners and body center. What is the packing efficiency? What is the packing efficiency? If the atoms, if the atoms along the body diagonal, the atoms along the body diagonal is removed, is removed without without distorting, without distorting geometry of unit cell, without distorting geometry of unit cell, without distorting geometry of unit cell. No doubt. Solution. Then now, if the atoms are at corners and body centers, number of atoms per unit cell equal to, for example, you can take an atom X, 8 corners, 8 into 1 by 8 plus body center. Then 2 atoms are present per unit cell. 2 atoms per unit cell. What they are asking, if the atoms along the body diagonal are removed. For example, this is the crystal. This is a atom 1, atom 2, atom at the body center. This is the body diagonal. What they're asking, these atoms are removed. Atoms along the body diagonal are removed. That's why A, 6 corners are there. 2 corner atoms are removed. That's why 6 atoms are there. Into the sharing of an atom at the corner is 1 by 8. Plus body centered atom is also removed. That's why no atom is there at the body center. No atom is there at the body center. Then which is equal to x 6 by 8, which is equal to x 3 by 4. Then 2 atoms occupies 68%. 3 by 4th atom occupies how much? Then x equal to 68 into 3 by 4 by 2, which is equal to 68 into 3 by 8. Approximately 25 percentage. Complete more? Complete ma?
Sir, complete, sir. Sir, complete, sir.
Okay. If face centered, if a face centered cubic arrangement of atoms in a FCC lattice, A and B atoms whose A atoms whose A atoms are at the corners of the unit cell or at the corners of the unit cell, and B atoms at the and B atoms at the phase centers. One of the B atom, one of the B atom is missing from one of the phase, missing from one of the phase in unit cell. The simplest formula of compound is the simplest formula of compound is then solution. A atoms are at the corners. The sharing of an atom at the corner is 1 by 8. B atoms, 6 phase centers are there. B atom is missing from the one of the phase. That's why B atoms 6 are there. One atom is missing. The sharing of an atom at the corner at the phase center is equal to, the simplest formula is A to B5. Complete, Amma?
Wait, sir.
No. All of you practice well and write the examination confidently. All of you revise all the formulae from solutions and solid state. Focus on ideal and non-ideal solutions, Van 't Hoff factor, depression in freezing point and elevation in boiling point, and osmotic pressure. Relative lowering of vapor pressure, P naught minus P by P naught equal to mole fraction of solute. Use P naught minus PS by PS. We didn't committed any mistake in the calculation. Get exact values. P naught minus PS by PS equal to mole fraction of the solute. Pi equal to ICRT, delta TF equal to I into KBM, delta TB equal to I into KV into M. For isotonic solutions, pi 1 equal to pi 2, I1 C1 equal to I2 C2. Then for the dissociation, Van 't Hoff factor I equal to 1 plus n minus 1 into alpha. For association, I equal to 1 plus 1 by n minus 1 into alpha. Then I factor equal to observed molecular mass by theoretical molecular mass, or observed colligative property by abnormal colligative property. Then colligative property proportional to number of particles present in the given solution. Molality equal to weight by gram molecular weight into 1000 by weight of the solvent in grams. P equal to Kh into X. Pressure, partial pressure exerted by a gas is directly proportional to mole fraction of the gas. Then Kh is inversely proportional to solubility of a gas. Partial pressure and mole fraction are directly proportional to the gas, solubility of a gas. Thank you, sir. Thank you, one and all.
Thank you.
Okay, sir.